Hello everyone, welcome to research presentation. This is Mahi Uddin here. I would like to describe uh, research presentation. Research title: the multi-featured entropy-based DDoS detection and mitigation method in software-defined networking SDN environment. Presentation outline: abstract, introduction, background of the study, research gap, problem statement, scope of research, summarized literature review, methodology, result and conclusion, and future work reference. So now I will briefly discuss on the outline of my presentation. Uh, First, I will explain the abstract and introduction. Then I will discuss the background of the study and identify the research gap. After that, I will explain the problem statement and the scope of research. And next, I will present the literature review and methodology. So finally, I will discuss the result, conclusion, future work, and references. Abstract. So there are four purposes: purpose, dataset, method, and outcome. So the research focus on developing a lightweight and real-time DDoS detection framework for software-defined networking environment. The framework used multi-feature Shannon entropy analysis to monitor traffic behavior. The five traffic feature used in the research are source IP address, protocol type, packet size, packet inter-arrival time, source MAC address. The experiment was a conduct using a mininet Wi-Fi SDN topology integrated with the rail controller. Two types of attract generated: TCP SYN flooding, UDP flooding. The purpose system continuously monitor traffic entropy values. When abnormal entropy behavior is detected, open for roles are automatically inserted to block malicious host. The framework achieved approximately 80% detection accuracy while maintaining network trouble during attract situation. This shows that the proposed method improved DDoS reliance in SDN environment effectively. This is the overview of abstraction. So now introduction. So now we'll discuss the introduction. Software-defined networking, commonly known as SDN in modern networking architecture. So in traditional networking system, the control plan and the data planes lightly controlled inside the network devices. But in SDN, these two planes are separated. The separation provides several advantages, such as centralized network management, better security, improved flexibility, easier network configuration. So, however, SDN also introduced security challenges. One major weakness is the SDN controller become a central point of failure. In attackers target the controller using distributed denial of service attack, the entire network may become usable. This attack forced the controller with massive malicious traffic. As a result, network service become unavailable, packet loss increases, dropout decreases, and network latency rise. To solve the problem, entropy-based traffic analysis is widely used. Entropy helps measure randomized and auto abnormal traffic behavior. Traditional entropy-based method mainly depend on a single traffic feature, which often leads to traffic positive and lower detection accuracy. So, therefore, the research process multi-feature entropy-based framework that combines several traffic attributes together for more reliable attack detection. So, literature review. So, in this section, I review server recent studies relation to DDoS attack in SDN environment. So previous research proposed various machine learning, statistical, and entropy-based technique. Some studies focus on high-rate DDoS detection, fast traffic discrimination, SDN traffic monitoring, flow-based security system. Although many approaches achieve good performance, several limitations still remain. For example, some methods are commonly expensive. Some require large training data set. Other only support specific attack types. Many fall to provide real-time mitigation. This motivated the development of lightweight and efficient framework using multi-feature entropy analysis. So, research gap. So, after reviewing previous work, several research gaps were identified. First, most exciting system rely on only single traffic feature. This include detection accuracy because attacker can manipulate traffic behavior. Second, many entropy-based approaches generated high false positive rates in dynamic network environments. Third, real-time automated mitigation is often missing is exciting system feature. Fourth, many slides focus only one attack type such as TCP/SYN flooding. So finally, very limited research combine multi-traffic feature like source IP, protocol type, packet size, inter-arrival time, source MAC address. So together, in one entropy-based detection framework, these gaps inspired this proposed research. This is the overflow of a research gap methodology. Research proposes a multi-feature entropy-based framework to detect and mitigation distributed dental of service DDoS attacking software-defined networking environments. The methodology is designed to analyze network traffic behavior in real time and identify abnormal pattern using statistical entropy measurement. Okay, so the explained methodology of the research. The research proposed a multi-feature entropy-based framework for detecting and mitigation DDoS attack in SDN environments. The methodology focuses several strategies. Stages first, network traffic is collected from open source switches and in the SDN controller. Then important traffic features are excited. Excited Next, Shawn entropy value are calculated. The entropy values are compared with predefined threshold. If abnormal traffic behavior is detected, the system identifies method host, a malicious host. Finally, overflow rule are inserted dynamically to block attacker automatically. The entire process works continuously in real time. Methodology, uh, model architecture. This is the model architecture of methodology. So the figure represents the overall architecture of the proposed framework. The architecture includes host, open source switch, rail controller, traffic monitoring module, entropy calculation module, detection and mitigation module, normal traffic flow through the network normally. So uh, during attack situation, abnormal traffic pattern reduce entropy values. The controller identify suspicious host and applies mitigation rule to stop malicious traffic. This architecture ensure continuous monitoring and fast response. This is the overview of model architecture proposed to work. Mitigation method in software-defined networking architecture like system architecture, multi-featured entropy calculation, two-stage detection and mitigation, experimental validation. So system architecture, this framework is integrate into the real SDN controller using the open flow protocol. The controller communicate with switches and monitor traffic statistics uh, continuously. So multi-feature entropy calculation. The system analyzes 5 traffic attribute: source IP, source MAC, protocol type, packet size, packet inter-arrival time. uh, the probabilities of these traffic attribute are calculated, then Shannon entropy is applied. The entropy equation used in the research is the multi-feature entropy calculation equation. E of x is equal less than p of xi log 2p p of xi. This is the equation of multi-feature entropy calculation. Here, this is the higher entropy generally includes normal distributed traffic, while lower entropy may indicate the behavior. Two-stage detection and mitigation. The framework continuously monitor entropy values. When entropy drops below the threshold, the system defines abnormal traffic, detect malicious host, insert blocking rules automatically. Experimental validation is the proposed framework achieved around 80% detection accuracy. The system also maintain network throughput during attack situation. This provides the effectiveness of the framework. This is our way of proposed scope of the research. Uh, Now I'll discuss the scope of research. This study mainly focused on detecting and maintaining DDoS attack in software-defined network environment. This research is limited to protocol-based flooding attacks separately: TCP, SY, and flooding, UDP flooding. The protocol framework targets attacks that after the SDN controller and reduce network performance. The study used Shandong entropy analysis based on 5 traffic feature. The implementation environments include mininet Wi-Fi emulator, open source switch, REU controller. The research does not focus on application layer attack and applied attack traffic, deep learning based method. Future studies can extend the framework for more complex attack scenarios. Dataset specification and preparation. So the part of dataset and the part of preparation. So uh, now I'll explain the dataset and preparing steps. Dataset information. The dataset was generated in SDN test environment. The environment include 5 hosts, one open source switch, one REU controller. Traffic types include normal TCP traffic, normal UDP traffic, TCP/S, YN flooding, UDP flooding, preparing step. First, traffic statistics were collected from the SDN controller and switches. Second, traffic was grouped according to selected features such as source IP, protocol type, packet size, time interval, source MAC. Third, probability values were calculated. Finally, entropy analysis was performed. When entropy values crops the threshold suspicious hosts were blocked dynamically using open flow rule. Result and discussion, training and implementation. So this is the shows training and implementation of the result. Throughput evaluate under different scenarios and throughput under different scenarios while the framework running. So this is the normal scenario during TCP SY and flooding, during UDP flooding, and suspicious action like normal scenario during TCP S2 flooding, during UDP flooding. This is the, I will discuss the implementation of the result, like the experiment successfully generated both normal and malicious traffic. The framework extended traffic feature from open source switches. Entropy values were calculated continuously. The system successfully identified abnormal traffic generated by DDoS attack. After attack detection, malicious hosts were blocked automatically. Network stability improved. Dropout rendered stable. The network achieved approximately 80% detection accuracy. This result demonstrates that multi-feature entropy analysis can effectively improve DDoS detection performance in SDN environments. Result and discussion of classification analysis. So uh, this is the classification analysis of average throughput under different scenario and average throughput in different scenario with the framework. So the normal average throughput under different scenario, uh, normal scenario 517, and during TCP as SDN floating 452, and during UDP floating 417, and average throughput after 1 by 10 seconds time arrival, 58.1 a normal scenario, and during TCP SDN floating 58.5, and during UDP floating 60.8. So the slide present the classification analysis of the proposed framework, the analysis compare normal traffic and attract traffic using entropy measurements. So the framework successfully defined malicious traffic pattern from normal behavior. The detection accuracy and mitigation performance indicate the combining multiple traffic feature improve reliability. So the also reduce false positive compared to single feature entropy method. This is the result and discussion of classification analysis part. So calculation. Finally, I will conclude the presentation. This research proposed a multi-feature entropy-based DDoS detection and mitigation framework for ASEAN environments. The system used review controller and OpenFlow protocol to monitor traffic behavior in real time. The framework successfully detected TCP as SYN flooding, UDP flooding attract by analyzing multiple traffic feature, unknown entropy values. Uh, Experimental research showed effective real-time detection, fast mitigation, improved network scalability, and approximately 80% detection accuracy. Overall, the proposed method provides a lightweight, efficient, and a practical security solution in SDN network. For future work, more attract types can be included. A machine learning method can be integrated. Detection accuracy can be further improved. Large scale SDN environment can be tested. So uh, the framework successfully detected TCP, SYN, and UDP flooding attracted by analyzing traffic feature and channel entropy values. Experimental result showed effective real-time attract detection, fast mitigation, and improved network stability. The proposed approaches provide a lightweight and efficient security solution for ASEAN environments. Thank you. Uh, References. These are the references used in the research. The reference include recent journal article and conference paper related to SDN security, DDoS detection, entropy analysis, OpenFlow based mitigation. Uh, these works helped build the foundation of the research. So, uh, thanks everyone and my honorable teacher right by me for listening my presentation. And do you have any question? I'm ready to answer your question. So thank you.